All right.
Mrs. Combs. I don't look good in the shot.
Oh yeah.
Welcome
Oh,
back to the last
Shit
show.
All right. So far, we've been going through sig figs, which those of you at home are probably well accustomed to. If you have questions, you can email me. We could even Zoom. I don't know that I remember the whole Zoom thing. We'll let you know that your textbook is waiting for you at the office, so you can come pick it up. And we've done conversions. And if you turn in your textbook to the inside cover, you'll find handy dandy bunch of conversions, and we've been going through doing some of those. You will get plenty of practice throughout the year. The new part that even if you were in chemistry, this is going to be new, is the percent uncertainty. There's always percent uncertainty in a measurement. When we use a balance, those are only so accurate, and then you get to a point where it's plus or minus a certain amount. Most of them, when you get them, especially the electronic ones, will say that it will weigh up to a certain amount and it has an accuracy, or it's actually more correct to say an uncertainty of plus or minus whatever 0.25 grams. That's how far it can be one side or the other. It's usually within that range. So you have a range of 0.5, half a gram that it's within. The more money you spend, the smaller that number gets, and it gets to be more and more precise. But we need to calculate the percent uncertainty. So let's do that. When they give you that, let's say that we measured something and it was a mass of 127.36 grams, and it's a plus or minus, let's say it is a quarter of a gram. What is the percent uncertainty? Well, we do this exactly the same way we do percent. If you got a 17 out of 20 on a quiz, how do you find your percent? Okay, and that gives me a 0.85.
Yeah, and then
You move the decimal point 2 spaces.
You multiply by 100 to make it a percent. Percent means per 100. Cent is just 100 in French, so percent just means per 100. If you ever wondered why we call it a percent, it just means per 100. If it's per mil, it would be per 1,000. That's what batting averages are in baseball, are per mil. So if you're batting a 302, it's 0.302, which is saying if Max was up to bat 1,000 times, he would get a hit 302 out of those times. That's the average that he's doing. That it's a per mil because it's always in thousand. This is percent. There's only the 100. So we find it the same way. So we're going to take how much air we're allowed, or what they say that we can have, 0.25 over 127.36 times 100. And this will be grams, and this will be grams, and this is why percents don't have a unit, because the grams cancel. So percents don't have a percent grams. It's just the percent. And I get, this one has 5 significant digits, this only has 2, so I'm limited to 2. So what is my percent error to 2 sig figs?
Or 0.2.
I get 2 sig figs. Give me one more digit. What are the numbers? 0.2.
Well, it's 0.196.
Okay. 0.196. 2. Okay, there, I can stop. All right, so I'm going to look at the second one. It says to round up, so this is going to be 0.20. I still need my 2. This goes to a 20 here. The 19 goes to a 20, so I still get that. So I get 0.20%, which means that's fairly accurate. Now, it all depends on what you're measuring. This is a fairly large, I mean, 127 grams isn't a whole lot. A pound is 454 grams. So this is, you know, a third of a pound or something, if you're measuring something. If we were on the same balance, we were measuring a paper clip that, let's say, is 1.36 grams plus or minus 0.25. Calculate what the percent error is in that measurement. And I would play along with you, but Max stole my calculator. But who knows, he could hold his service weapon on me if I didn't say yes, so.
It's about like 18%.
Yeah.
Okay, so now it's the same balance, and before, I'm pretty happy with 0.2% error. That's not bad. I'm still using the same balance, now it's giving me 18%. That's not good at all. I mean, if you're within 18%, you really have no idea how much that paperclip weighs. 1.36, but it could be all the way up to 1.61, or it could be all the way down to 1.11. That's a huge range in there. When the smaller the number, the larger the percent error is going to be. Same thing like with I think one of the problems you're gonna do later says a handheld stopwatch, it has a half a second error because it's your eyes, your reflexes to start and stop. Turns out to be about half a second.
Oh.
That's gonna be a huge amount if you're timing somebody in the 100-meter. Because a lot of times they're finishing in like 12 or 13 seconds. Half a second could be the difference between first and fourth. They're running that close a lot of times. A lot of error. If you're timing somebody in cross country and they're running 20 minutes, half a second is going to be a tiny, tiny error. So the bigger the measurement, the smaller the error. So it doesn't mean that they did a bad job on this, it's just that it's down to the accuracy of the equipment, and this is such a small one. Now, if you were measuring something that was really small, so you found it to be 0.23 grams plus or minus 0.25 grams, you can see that we're just guessing at what it is. Somewhere between 0, because you can never have less than that, to 48 grams. I mean, that's a huge percent error in there. That's going to be over 100% error in that. Now, a lot of times, they aren't going to give you the amount of error. So if we just measure something to be 487.33 meters, and you want to know what the percent error is in that. If it's not given, we assume that the error is going to be human error, and it's going to be in your last little bit where you measured the 487.3, and then you get that one place of uncertainty where you're guessing at that one. And it was from this mark to this mark, and it was right there, and you guessed that that was 0.3. Like I said, we usually assume that you are going to be within 1. Some of you might look at that and say, that's 0.2. I don't know if I'd go 0.3, but I'm going to guess on that. Most of you would say 0.2 or 0.3. I don't think it's the way I would go to 0.4. That usually we're within 1 of what it is. So we assume that it's going to be one of whatever that digit is. So in this case, it's 100, so we would take 0.01 divided by the whole measurement, 487.33, and then it is a percent, so we'll take it times 100. Jesus, fire up those calculators.
Where did you get the 0.01?
It's one of whatever the last place is. So this goes to the nearest hundred, so it'll be 1/100.
So even if it's not 3, if it's like 9, it's still not 3.
Yeah, it's just one of whatever that is, yeah. What'd you get, JC?
0.002.
0.00, and then what are the actual numbers?
2051.
Yeah, okay, so that's what, and I only get one significant digit because this is only one significant digit, so 0.002% error is what I get. Now again, the better the instrument and the larger the measurement, the error is gonna be smaller. If we did something that was 14.1 centimeters, well, let's say 14.4, because otherwise somebody's gonna get confused at why I use the 1. Now I get one of the smallest one. So I get one of these, so it'll be 0.1. Now it's a tenth. Here I went to the hundredth, here it only goes to the tenth, so 0.1 over 14.4, and again, we'll make it a percent times 100, and this one, still not gonna be huge, but it's gonna be much larger than what the 2/1000ths of a percent is.
0.069.
So 0.07, because I still only get one place, 0.07%. Now, if you had a ruler, I don't know why you use this, but you can see that if we just had a ruler and we had 0, and this was 10, whoops. That's not, well, that'll work better that way, okay, start over. Let's call this one 5. Okay. And so that's 10 centimeters, obviously blown up here. And we say it's right there. Okay, so what would you measure? How many centimeters would that be?
3.8.
Okay, she'd say 3.8. I'm gonna guess that none of you are gonna be off by more than 1, although somebody might jump to, it might be 0.9. I don't think you'd say 7, I think I'd agree with her that 8 would be better. But some people might say 9, so, but we are guessing at this one. So we're gonna be within 1 of that, 0.1 over 3.8 times 100. So just as easy as what the others are, if it says 3.8 plus or minus 0.0, well, or plus or minus 0 point, let's say 2, then I would take, if that's there, I would take the 0.2 over 3.8 times 100. If this isn't there, if it's just the 3.8, we assume it's just one of those. All right, any question on that, finding the percent uncertainty? Some things will give you the plus or minus. Others just assume that it's accurate, it's just gonna be your measurement, your assumption at the end.
So you know you have the plus minus 0.2.
Yep.
If you don't have like that one, or if it has just has 3.8, is it always gonna be 0.1 on top?
It's always gonna be one of whatever the end is. If you have something that says 350 gallons, this is the last significant digit, and it's in the 10 spot. So that would be 10 over 350
Oh, so then.
times 100.
Okay, so then if it was like, let's say it was like the 3, it'd be 100 over.
Yes.
Okay.
Yep. It's whatever the last significant digit, what that place is, one of them. Any other questions? Easy peasy. Colton, you have any questions? He doesn't. He's got this. All right. Then, I know, heavy, I'm gonna let you get started on it. Here we go. Enjoy.
I probably won't.
Ooh, nice catch.
Yeah, this is okay.
You may.
Thank you.
All right, and Colton, this will be in the files of Canvas. Email me if you can't get it there, and I'll stick one in Sick Ed. I'm not supposed to, because I'm supposed to push you to Canvas, and we'll get you there, but I also want you to get caught up. I think in Sick Ed, I've actually put the other 2 assignments, so you should be able to find them there. I will put them in Canvas. If you have any questions, you can email me.